based on cardinal number of sets. So as we discussed, cardinal number of a set basically tells you the number of elements in the set. Now these properties are going to be very, very important because later on when we are studying chapters like probability and you have to count the number of favorable events or the number of events in the sample space, you would need this property, especially in the addition theorem of probability, which again you are going to study in this year itself towards the end. Now what are the properties of cardinal number of set? The very first property that we are going to study is the number of elements in A union B. The number of elements in A union B is equal to number of elements in A plus number of elements in B minus number of elements in A intersection B. Okay?
What's answer there? Your hands are there.
We may not also discuss it. We will continue with relation function because again I have to complete this. Not exactly 1 hour, but yes, half an hour or 45 minutes. Anyway, this is recorded. Okay. Now, the proof of this is very simple from the Venn diagram. Let's say this is set A and set B. Let's say this zone contains K elements. This zone contains L elements, and this zone contains O elements. Okay. Now I want K plus O plus L, which is nothing but KA, which is K plus O, KB, which is O plus L, minus intersection, which is O, so which gives you left hand side equal to right hand side, right? Now this property can be extended even for 3 sets.
So for n number of sets.
Where the formula becomes NA plus NB plus NC minus NA intersection B and B intersection C and C intersection A plus NA intersection B intersection C. Okay. This formula is better known as the inclusion-exclusion principle.
So this is what they were going on about in those article suggestions.
Yeah. It's very important with respect to your Olympiad syllabus, right? And you will find this principle being used in permutation combination chapter in derangement, right? Derangement is basically based on inclusion-exclusion principle.
How many ways you can arrange something such that no such thing retains its original position?
Yes. So how many ways can you derange things? That is being covered by derange. Arrange, opposite is derange. We'll talk about it in this thing. Now as Sukir said, this can be extended to n number of sets. Here you have to identify the pattern.
Yeah, it will be minus plus.
The pattern is, yes, the pattern is first you add them 1 at a time, then you subtract them 2 at a time, then again you add them 3 at a time, again you subtract them 4 at a time. In that way it goes on and on.
It's sort of like that side and to the
Right, so you include, you exclude, you include, you exclude, like that it goes on. Okay, so let's say if I have,
So wait, so please give some.
if I have 4 sets, A, B, C and D,
Oh yeah, okay fine.
then how do I write this principle?
N of A plus N of B plus N of C plus N of D
Okay,
minus
N of A, N of B, N of C, N of D,
minus N of A intersection B intersection C plus
and A intersection D
intersection
B intersection C,
Build up.
C intersection D, D intersection A,
B intersection D, and
then B intersection D, and A intersection,
the B intersection D.
and A intersection C. Okay. Plus 3 at a time, and A intersection B intersection C, and B intersection C intersection D, and C intersection D intersection A, and then A intersection B intersection D.
Sir, is there a way to
Generalize it, yes.
no, sir, should we oh yeah, we have to subtract the one before.
Minus N intersection B intersection C intersection D.
Yeah.
Is there a convenient notation?
You can write summation 2 at a time plus summation 3 at a time minus summation 4 at a time. Just like we did it in the formula of tan.
Plus minus plus minus.
Plus minus plus minus. That's why the name is include, exclude, include, exclude. Is that okay?
Yeah.
I told you no, the generalization is summation 1 at a time minus summation 2 at a time minus summation plus summation 3 at a time minus summation 4 at a time plus summation 5 at a time like
So
that.
is that end of A, union B, union C, union D?
Sigma K is equal to 1. Sir,
Sorry.
maximum generalization is it? It is sigma K is equal to 1 in minus power of n pi n c K 1 till K all permutations. But here I couldn't generalize much because like you have to choose
That's
all
what-
permutations, right?
Yeah.
Sir, in school level, what number?
School is still this level.
3.
3.
K can ask like
Okay.
5 or something.
They mostly use this for sets. Sorry, permutation combination. Okay.
Look, this is general formula. Huh? And
By the way, in the language of sets, we read this as number of elements in at least one of A or B.
Yeah.
Number of elements in at least one of A, B or C. Is that okay? At least means it can be one, more than one, it can be 3 also. Is that okay? So read the language written in your question paper and try to relate it with the language of sets. Okay? If they say A and B means A intersection B. Can I erase this?
Sir, could you please give some definition?
I'll see if I have it.
K, I.
Should I erase this? Sugosh? If your hair has come out, then can you solve some problems? Okay. Can you give me an expression, those who have already done this, can you give me an expression for the number of elements falling in exactly 2 of the sets in A, B and C?
So what?
Can you give me an expression in terms of NA, NB, NC and their intersection 2 at a time or 3 at a time?
Oh, expressions.
The expression for the number of elements falling in exactly 2 of the sets.
Sir, are we
So you
giving
can
a
just
total
you can just make it
Ranya.
one side. Yeah, that's what I thought.
Exactly 2 of the sets.
So you can just make this come this side, that's all.
Yeah.
And you can make this come this side and subtract your intersection of all. The second
Sir, are we given
part.
the total number of elements?
The second part you can
You
shift
know
it
the
to one
total number of
side.
elements in A, B, C, intersection of A and B, B and C, C and A and all intersection.
And okay, then that's very easy. You have to find any way.
Oh, general again.
Find the number of elements falling in exactly and C. If I show it by a Venn diagram, I need this area. You can only use NA, NB, and C. NA intersection B, NB intersection C, and C intersection A, or intersection of all of them together.
Find out. Sir. This is no, I was wrong. But here, that's
Absolutely correct. So Ashutosh says n of A intersection B, n of B intersection C, n of C intersection A or A intersection C minus 3 times. Is it correct?
yeah.
It's obviously correct because the first term is this entire thing, second term is this entire thing, third term is this entire thing. When you realize that the middle part comes next.
Is the pattern here odd numbers? 1 then minus 3 plus 5, something like that. Does it work? Like the pattern. Now if I tell you for A, B, C and D, so will it be n of this minus 3 n of that plus 5 times that?
There will be a pattern, definitely there will be. Okay, let's find out the number of elements in exactly one of the set. Exactly one is which diagram? It will be like this. This is falling in exactly one of the sets.
So you just take N of A, N of B, N of C. Okay. And then subtract the expression from there.
Yeah, that's all.
And then add one.
Exactly.
No. B. Why do we need that? Coming to take it out. Twice we have to add one.
After that, we'll take few questions and then we can start relations.
Sir, it will be it'll be A plus B plus N of A plus N of B plus N of C minus N of A plus B minus N of B plus C minus N of C plus A. How is A plus? This will work out. Yeah, because subtracting there's nothing that's N of A plus B plus C minus this. Yeah, and you can even exclude the 3 M.
N of A union B union C minus this.
N of A plus N of B plus N of C minus this expression.
Yeah.
No.
This part is missing from it.
So is it N of A minus N of A?
Yeah. All of
we've removed
So we
that
removed
same
the-
part twice. So now it will be N of A plus N of B plus N of C minus N of A intersection B plus
minus
N of C intersection B plus
What?
N of C intersection A.
No.
Plus 2 N of A intersection B intersection C.
The first, sir, you can just do N of A plus N of B plus N of C. Then you can just subtract the first 3 terms. That's all.
N of A
Plus N of B
can you all be quiet?
plus N of C minus N of
Okay, now see it.
Yeah.
While you're doing that, this part has come twice.
Yeah.
Correct?
Each one of the
Oh damn it.
In N of A and N of B it has come.
2
This
times.
part has also got twice, this part has also come twice, correct? So you need to subtract 2 times N A intersection B and B intersection C and C intersection A.
Sorry, sir.
Okay, but when you're subtracting this twice, this is coming in 2 of the right. What is happening to this? This is getting subtracted how many times?
6 times. 6 times.
No,
So you have to add
Three times.
So in this already it is present 3 times.
Minus
Minus
3.
6 times.
Minus.
So I am deficit by 3 times.
You have to add.
So minus.
Oh. Because you have to take the n of a1 and n of b2 minus.
Is that okay?
So why minus?
Minus 2 is because in NA and NB it is occurring 2 times.
Intersection comes with.
Intersection comes always twice. Is that okay? So these are some theorems or properties on cardinal number of sets, and we can start solving problem based on this.
So now when you draw the Venn diagram for that, first you have n of a and all that, and then when you subtract 2 times n of a plus b, when you do it on both sides, you don't need to add it again, right? Because when it's subtracted, there's anyway nothing to subtract.
Which one?
Like if you're saying, if at all you're saying
Ananya, Anika, both come this way. Yeah.
so if at all you're saying a minus b, so let b have few elements which are not there in a. So when you subtract b from a, like you're just removing the elements which are the intersection of a and b. You're just excluding. So if you add 3 times that, you're going to get it back. Like now you're anyway subtracting 2 times that thing. So everything is going to get removed anyway. You don't need to add that.
No, but it has created a deficit there of minus 3. I have to create it as 0.
Okay, fine.
You are over subtracting.
So then even in a minus b also you over subtract.
Here the common zone, this part is included 3 times.
Yeah.
But here you removed it 6 times.
Yeah.
So you have to refurbish.
So even in a minus b, you're over subtracting some elements in b, right? So now if a has 1, 2, if a has 1 and 2, b has 2 and 3. When you're doing a minus b, you're also creating a deficit of 3, right? In b, a minus b.
Will be 1. Saying 3 of b is gone. 1, 2 and 2, 3. When you do a minus b, will be 1, right? The 3 of the b is gone.
So where is it happening? I'm not able to relate your problem to this problem.
Oh wait, that is different. Yeah. It's not.
Okay, questions?
No.
Let's start with questions. First question, write down. Now this is a word problem.
Just coffee things. Coffee, tea.
English bad.
No coffee and tea.
Number of students who pass in English and maths. Football, cricket, basketball. Who passed in examination?
First question.
Morning walk.
First question. Suppose.
Stop talking, please.
Suppose. A1, A2 till A30 are 30 sets, each with 5 elements.
Oh wait, this is okay. And then suppose b1, b2,
And B1, B2 till Bn are n sets with 3 elements each. So this each has 5 elements.
Yeah.
Each Ni has 5 elements. Each Bi has 3 elements.
So you roll 10 now.
Let union of AIs from I equal to 1 till 30 is equal to union of, let me call it as Bj.
So is it proving? No, right?
And this is equal to S.
This is?
repeat from the first.
What is wrong?
What?
There are 30 sets A1, A2, A3, each having 5 elements. There are n sets B1, B2, B3 till Bn, each having 3 elements. And the union of all the sets are same. There are n sets will sum it till n, right? Assume that this line is very important. Note it down. Assume that Each element of S belongs to exactly 10 of the AIs.
What?
Assume that each element of S, the union of all the sets,
Yeah.
each element of S belongs to exactly 10 of AIs. Okay? Let's say there is an element 2. It will be found exactly in 10 of AIs, means it may be A1, A2, A5, A7, A18, like that, 10 of them. And it's found in exactly 9 of the BJs.
Oh my god.
And is found in exactly 9 of the BJs.
So then, find what?
Then find it.
What?
Oh, that's easy.
Should I write it down? Each element
There are 5 elements.
of S belongs to
There are total 50 with 10
exactly
How do you know if they're not disjointed?
10 of AIs. And each element of S belongs to exactly
I know that there are 15 elements in total.
Okay, you're the genius.
9 of BJs.
45, sir.
Find it.
45.
Correct.
I sent this problem for you.
And me in the group, what are you doing? I'm going at this one.
So could I solve it on the board, sir? No.
Just give them some time, then I'll call you on the board.
So no, see you later.
This is an RMO.
No, this was an article.
Why am I finding it out?
It's not an RMO problem, it's an RDS
Try
problem.
this, I can do this.
I've just done it once, like about 4 to 5 weeks ago. 4 to 5 what? Weeks ago. No, 4 to 5 weeks ago I did it.
Okay. Any idea?
No, wait, sir. 2 more minutes.
Don't waste time. Sir, no hint, sir. No.
Yeah, no hint, no
Sir, I
hint.
started with the
The start is the end of the block.
Yes, sir, actually. Start is the end of the problem. Consider how many elements there are in it. I've given too much away already.
Consider how many distinct elements
Elements are there in it.
Distinct.
Yeah. I've given away too much.
Oh, wait. So we assume everything is distinct or something like that.
No.
Come on. Oh wait, I can assume it like that, right?
Yes, everything
It's
has
true
to be
for
distinct.
everything.
Yeah, but if you just add the elements of A, they are not going to give you all the
Okay,
elements.
fine. One minute.
Aruna, your WhatsApp profile is you.
Exactly 10 elements is S. No, it's not equal. Okay. Assuming that 10 will be 50 systems. There are 50 elements. So
He still has a share.
50 elements in this. Then you want to be 10 more. Now
Okay. Answer is 45, yes. Sami? You either get it or you don't get it. It's so simple like that. It's very simple. See it.
Sir.
should actually have distinct elements because we learned set is a well-defined collection of distinct objects. So every element is coming 10 times. That's why your total became 150. So ideally one element was present 10 times in all the A's, right?
Yeah.
So actually number of elements was 150 by 10, which is 15.
Then the similar logic would be equate element.
So in a similar way, if you just dump all the elements and divide it by 9, both of them would be equal because in a set the number of elements are distinct and equal. So this gives you n as say hello.
So this is
Take it. Yes.
Oh, I completely forgot the second part.
hand sanitizer.
You have
Hand sanitizer.
I forgot that.
Wait, no,
The union of set A's and set B's are same.
the bathroom
Is that okay? Next problem, guys. Those who want to leave can leave now. Next problem.
hand sanitizer. Hand sanitizer.
Write down in a very crude way, in a very raw form. Please listen to this very carefully. It's a word problem. So Ghosh, it's a word problem and I'm not going to repeat it more than once. In a pollution study of 1500 Indian rivers, in a pollution study of 1500 Indian rivers, pollution, pollution, water pollution, it was found that 520 were polluted by sulfur compounds.
How many?
520 are polluted by sulfur compounds.
So can you just tell how many different compounds are there so that we can draw the sense?
335 were polluted by phosphates. 335 were polluted by phosphates. If you talk, you miss the data. Samir.
I'm writing some.
425 were polluted by crude oil. 425 were polluted by crude oil. 100 were polluted by both crude oil and sulfur compounds.
100. So can you tell the last information first?
180 were polluted by both sulfur and phosphates. 180 were polluted by both sulfur compounds and phosphates. 150 were polluted by both phosphates and crude oil.
What? Sulfur and phosphates what? 120.
180 were polluted by both sulfur and phosphates. 150 were polluted by both phosphates and crude oil.
Yes, sir, we do.
28 were polluted by sulfur, phosphate and crude oil.
Phosphates and all three 28.
All three.
No, before that.
I'll repeat the data. Let me complete the question. It creates confusion repeating the same data twice. Question is, how many of the rivers were polluted by at least one of the three impurities? That's question number 1. Question number 2 is, how many of the rivers were polluted by exactly one of the three impurities?
Yes, sir.
Now I'll repeat the question once again. Listen to this very, very carefully and don't stop me in between. In a pollution study of 1500 Indian rivers, 1500, the following data was reported. 520 were polluted with sulfur, 335 were polluted with phosphates, 335, 425 were polluted by crude oil, 100 were polluted by both crude oil and sulfur, 180 were polluted by both sulfur and phosphate.